All right, so in this lesson, we are going to discuss some vocab of even and odd functions at first, and then we are going to just discuss the difference between f of negative x and negative f of x, and these directly relate to even and odd functions. So first, I'm going to talk about even functions. Now, in your packet, you would see an even function is one whose graph is symmetric with respect to the y-axis. So my first function I am going to pick up is this one here. So I've just cut out a bunch of random functions just to display this for you. So this function here, remember the y-axis is right here. If I pick this function up and flip it over the y-axis, it looks like the exact same function. I could move this function down here, and it would do the same thing. If I flip it, it is symmetric about the y-axis. Now this makes this function even. Now if I were to move this function to the right, it would no longer be even because flipping it over the y-axis would do this, and that does not land exactly on itself. So it's important that the middle of the function for an even function is on that y-axis. If it's even off slightly, it is not going to be the exact same function when it's reflected over the y-axis. So that's our first even function. The other even function that I've cut out is this one. If I put this centered on the y-axis, I can flip it over and it is the exact same function. Now if I moved it up, flipped it over, exact same function. So even functions are functions that are symmetric with respect to the y-axis. So they can reflect over the y-axis and they remain the same. Keep in mind, if I were to move this one here, because it only has these two parts, if I were to reflect this over the y-axis, it is no longer even. So again, the middle point of the function is on the y-axis and it does the same thing on either side of the y-axis. So there is my even functions. Now I have a couple of different odd functions to show you. Odd functions are not the same as even. Instead of being symmetric about the y-axis, they are symmetric with respect to the origin. So let's keep in mind that the origin is where the x and y-axis meet. And in your notes, you'll see that it says that the graph would look the same when rotated 180 degrees. So that's exactly what I'm going to do. I have a point at which I'm going to rotate it around. It has to be the origin. And if I rotate this 180 degrees, notice it looks the exact same. If I rotate it 180 degrees again, exact same. So it is important that you recognize that it has to be 180 degrees rotated, and then it gets you the exact same thing. So I'm going to show you another example of this. This one's a little bit more basic. If I put my center point at the origin and I rotate it around the origin 180 degrees, same line. So that's an odd function. These are both odd functions. Here's the difference. Before, in the even functions, it only mattered if the center point was on the y-axis. If I were to move this down here and I rotate this 180 degrees, it is no longer an odd function. So this one, it's important for an odd function that it goes through the origin. There are a couple that don't go through the origin, but not many. So you're really looking for, if you centered it around the origin, rotated 180 degrees, is it the same? So I'm going to show you one more function that comes out being odd. Here's my next function. So I tried my best to make this symmetric. It was not easy to cut out. if I rotate around this one point 180 degrees, so I'm going to start here and I rotate. Notice what the function looks like. Oh, it is still the same function. I'll do that one more time. So if I start at the middle, notice I'm rotating about the origin, 180 degrees, same function. So that is the difference between even and odd. Even, it has symmetry about the y-axis. Odd, symmetry about the origin. Even is the exact same graph when it is reflected over the y-axis. Odd is the exact same graph when it's rotated about the origin 180 degrees. So now one more thing that I want to point out before we actually get into how to tell if they're even and odd algebraically is the difference between f of negative x and negative f of x. So let's say I have f of x equals 2x squared minus 3x plus 1. I'll zoom in down there now. So I have 2x squared minus 3x plus 1. Now, if I'm doing f of negative x, that means I'm replacing each x in my original function with negative x. So let's look at what that looks like for this function. That would be 2 times negative x squared minus 3 times negative x plus 1. So notice what changes is the negative x's in here. On the other hand, when you have negative f of x, what that does is it takes the entire function, 2x squared minus 3x plus 1, and it multiplies it by a negative 1 out in front. So this one, you're applying the negatives within the function. Negative f of x means you're multiplying the function by a negative 1. I'm just going to quickly evaluate these so that you can see how that works. So if I'm doing f of negative x, think about negative x squared. Since I'm squaring it, that would be the same thing as just x squared. Because anything to an even power that's negative is going to come out positive. So that'd be 2x squared. This would be plus 3x now, plus 1. Over here, if I distribute this negative 1, I have negative 2x squared plus 3x minus 1. So notice how f of negative x got me a different answer than negative f of x. And that's all based on where you apply the negative. So these are the key concepts that are going to help you get to the access to the information for even and odd functions. Make sure to watch the following videos for specific examples and how it actually works algebraically.